Hello everyone, I'm Sana Kashif Sheikh, Assistant Professor, Department of Computer Science, Abeda Inamda Senior College. Welcome to the series of Database Management System. Today we are going to see Introduction to Database Management System. Now what is database? Data is nothing but piece of information and we are going to store all this related information somewhere that is called as Database Management System. Database is a collection of interrelated data which helps in efficient retrieval, insertion and deletion of data from the database. So that means if data is properly stored, so retrieval, insertion and deletion becomes more easier. Database organizes the data in the form of tables, views, schemas, reports, etc. For example, University database organizes the data about students, faculty, and admin staff, etc., which helps in efficient retrieval, insertion, and deletion of data from it. In DBMS, we use SQL, that is Structured Query Language, to define and to manipulate data in the database. Next topic is file system versus DBMS. File system is a software that manages and organizes the file in a storage medium within a computer. DBMS is a software for managing the database. Redundant data, that means duplicate data, can be present in file system as we are not properly organizing the data, so there can be duplication. In DBMS there is no redundant data, that means duplications are not allowed. It doesn't provide backup and recovery of data if it is lost. Your DBMS provides backup and recovery of data even if it is lost. There is no efficient query processing in file system. There is efficient query processing in DBMS. There is less data consistency in file system. There is more data consistency in DBMS because of process of normalization. File system is less complex as compared to DBMS. DBMS has more complexity in handling as compared to file system. File system provides less security in comparison to DBMS. DBMS has more security mechanism as compared to file system. File system is less expensive than DBMS. DBMS has comparatively higher cost than file system. So little bit DBMS is little bit more costlier. Next topic is abstraction and level of abstraction. Now what is abstraction? Abstraction means hiding something. So here is an example of a capsule. When you open the capsule, there are medicine inside. That medicines are of type 2, 3, okay? We just see the granules of medicine and we see that the capsule is only one tablet, but in capsule there are more medicines. Okay, now for us the capsule is only one tablet, so we know only that much, how much the developer shows us, correct? That is called abstraction. Abstraction means hiding the irrelevant data from the user and showing only the essential data. That is called abstraction. Database systems are made up of complex data structures. So, to ease user interaction with database, the developer hides the irrelevant data from the user. This process of hiding that irrelevant data from user is data abstraction. So here your database is made up of complex structure. Okay, now where it is stored, how the data is getting stored, and in which format it is getting stored, that is none of the business of user. So user only know that much, how much it is required for user to use the database. That is called as abstraction. So we have three levels of abstraction: physical level, logical level and view level. So we are going to see each level in detail. We have three levels of abstraction. First is physical level. This is the lowest level of data abstraction. It describes how data is actually stored in database. You can get the complex data structure detail at this level. So where the data is stored, how the data got stored, how much memory it is required, that all details come into physical level. Next is logical level. This is the middle level of three level of data abstraction architecture. It describes what data is stored in the database. So it tells you what data you have stored in database, like integer and character, float, in which format you have stored, how much space you have given. All this comes into logical level. Next is view level, highest level of data abstraction. This level describes the user interaction with the database. So when you interact with the database using forms or using software, you are entering some data, and that data is getting stored into database. That comes into view level. So in view level, you doesn't know about the logical level and physical level. That means what data is getting stored and how data is getting stored. You don't know that. You just know this is the form, and I have to fill all the details of my form, and my details will get stored somewhere into the database. For example, let's say we are storing customer information in customer table. Okay? At physical level, these records can be described as block of storage, that means byte, gigabyte, terabyte, etc. in memory. These details are often hidden from the programmer, correct? So at physical level, it describes that how much memory it is required, how data blocks are made of bytes, gigabytes, etc. Okay, so the user doesn't know all this detail when he is using the database. Next is at logical level, these records can be described as fields and attributes along with their data types. The relationship among each other can be logically implemented. The programmers generally work at this level because they are aware of such things about database system. So at logical level, what data we are storing, how we are storing, okay, what data types we are using for storing, what is the relationship between all these attributes and all these tables, that comes into logical level. So even at this level also, user doesn't know this level also, okay, how my data is related to the other data, how my data is getting stored into the table. At view level, user just interact with the system with the help of graphical user interface and enter the detail at the screen. They are not aware of how the data is stored and what data is stored. Such details are hidden from them. So at view level, user is just entering their data. The data is getting stored into the database, but user does not know the background detail, that how what data is storing and how the data is storing. Clear with data abstraction and level of abstractions? Next topic is data independence in DBMS. Now we have seen that we have divided the abstraction into three levels, correct? Physical, logical, and view level. So that means we have three levels, okay? One level doesn't know about another level, okay? Now suppose after certain time you feel that my memory is not enough to store the data. So I can increase my memory, correct? But if I increase the memory, can I hamper with the data? Can my data be changed? No. Why? Because here we are following the data abstraction level. If we are changing our storage medium, our storage size at physical level, my logical level should not get affected. Okay? Similarly, at logical data independence means what? If I'm changing the data type of my data, okay, or if I'm changing the structure of my table, I'm adding some column, I'm deleting some column, my view level should not get changed. That means my form should not affect this, okay. User should not need to know that the tables are changing inside, okay. So this is called as data independence. That means changing or modifying the schema at one level should not affect the another. Data independence is the ability to modify schema without affecting the programs and the application to be rewritten. The main purpose of three level of data abstraction is to achieve data independence. If data changes and expands over time, it is very important that the changes in one level should not affect the data at other level of database. This would save time and cost required when changing the database. There are two levels of data independence based on three levels of abstraction, that is physical data independence and